polar coordinates is a brand new topic you've never heard before. So far in all of your math life, you've only known one coordinate system. And that is what we call the Cartesian coordinate, the X and the Y, right? That's the only ones you ever heard before. Today we're going to talk about the polar coordinates. And polar coordinates is you start from a pole. You have a pole here. You start from here and you swing over. Okay, so if you go up to here, and we're going to call this coordinate R and theta. R being the length, theta being the angle. Okay, so if you put this on and think about it in a Cartesian coordinate way, the coordinate here would be what? What would your coordinate? What would your X coordinate be here? Since this is R and this is theta, wouldn't it be R cosine theta?
Wouldn't R cosine theta be the length of the bottom?
Yeah, so it would be this guy right here, right? This would be R cosine theta, right? So your X is going to be R cosine theta. Similarly, your Y would be what? Your Y would be R sine theta, correct? Okay. So this is the relationship between your polar coordinates and your Cartesian coordinates. Okay, not too bad. I'm going to throw a little bit of a monkey wrench in here. I can actually go from here all the way across to here and say I went from here to, this would be what? Theta plus what? Which would be, yeah, so it's theta plus pi, correct? In radians, right? Theta plus pi. And instead of going here, I can go backwards and end up here. Does that make sense? Magnitude-wise, instead of going from here, so R, this guy here would be what? R and theta plus pi. I can write this as a negative R theta plus pi, and it will be the same point. So from here, instead of going positive R, I'm going negative R. Does that make sense? So I'm going to go, my angle is going to go from here to theta plus pi. And then instead of going from here to here, R, I'm going to go here to here, negative R. So negative R, theta plus pi. Also, this guy can be what? This guy's really, right? Because I can go theta and I can go roundy as many times as I want, right? Okay, all right. So that relationship, okay, so that's not done. So let's go ahead and do example. Okay, so let's go to flip the page, go to 488. Go to 488. So R, that little violet, purplish box, finding all polar coordinates of a point. R theta plus 2n pi, R theta plus 2n pi, and this is actually going to be, instead of pi, I can also go 2n plus 1 pi, right? I can go 1 pi around and then go roundy as many times as I want, just as I did this one over here, like this one here. So it's a negative R theta plus 2n plus 1 pi. And so let's go ahead and see if we can go back to example number 1 and example number 2 and figure this out. So let's do example number 1. Example number 1, plot the points with a given polar coordinate system. So I go, the first one is going to be here, and I'm going to go here, and this is going to be 2 and pi over 3, which means that this guy here is going to be pi over 3, 60 degrees, right? That would be 1. So this is example 1, and this is 1. 2, or B, I guess, is negative 1, 3 pi over 4. So I'm going to go here, 3 pi over 4, which is here, but I'm going to go negative 1 down this way. So I go here, 3 pi over 4, and then instead of going for positive 1, I'm going to go negative 1 down that way.
So our angle would be the obtuse one?
Yeah, the angle is right here, right? 3 pi over 4.
Okay.
And then the last one is 3 and negative 45. And this is degrees. All of a sudden they're going to put you in degrees. So we're going to go here. We go negative 45 and 3. Okay. Example number 2, find all polar coordinates for a point. So the point is 3 and pi over 3. So it's actually this guy here, almost this guy, because this guy is 2 and pi over 3. We're going to call this just 3 and pi over 3. Okay, so another one would be 3 and pi over 3, and then I can go 2 and pi, right? So I went from here to here, and I can go around as many times as I want. Or I can go from here another 180 degrees over here, and then go backwards, right? So that would have been pi over 3 plus pi. And it would have been negative 3. So this would be what, 4 pi over 3, I guess? Plus 2 and pi. Right? So on this one, I went from here, pi over 3, another pi to go over here. Then I went negative over here, negative 3. Right? Number 2. Now let's go to page 488, middle coordinate conversion equations, where we talked about this. You already said that x would be equal to r cosine theta, y would be equal to r sine theta, and we could also say that the tangent of theta would be what? X over y. We can also say that this squared plus this squared. So x squared plus y squared would be r squared cosine squared, r squared sine squared. So it would be r squared times cosine plus sine squared, right? Cosine squared plus sine squared, and that's 1. So we get this guy, and that's in the middle of page 488, middle of page 488. Example number 3, converting from polar to rectangular. So let's go from polar to rectangular. Example number 4, which is what we just did here, right? So if I have A, using an algebra to find the rectangular coordinates, identify the rectangular coordinates. So I have P, which is 3 and 5 pi over 6, is it? 3, 5 pi over 6. So my x coordinate would be 3 times cosine 5 pi over 6. Y coordinate would be 3 sine 5 pi over 6. What is cosine 5 pi over 6?
Good question.
Is it positive or negative?
Positive.
Why? It's in what quadrant is it in? Second quadrant, so cosine would be negative. Cosine's positive in first and fourth quadrant, right? So second quadrant, this is going to be negative 3. This is going to be root 3 over 2. This guy here is going to be sine. So it's sine, which means sine is positive in which quadrants?
2 and 3.
1 and 2. 1 and 2. And this is second quadrant, so it's going to be positive. Okay, so that's your answer right there. B, 2 and negative 20. Negative 200, I'm sorry. Negative 200, positive 200. Negative 200. Okay. Which is the same as what? Right? Same as 160? Right? Because I can go here and go around negative 200 this way, or I can go from here and go positive, go that way, 160, right? All right. So my x is going to be equal to 2 cosine 160. Y is equal to 2 sine 160. Again, we are in the second quadrant. This is going to be a negative number, and this guy's going to be a positive number, right? I don't know what cosine 160 is. Whatever you turn, you plug in your calculator, whatever you get. Looks like x is going to be negative 1.88. Y is going to be equal to 0.68. Okay. Example number 4, going from rectangular to polar. So let's go from rectangular to polar. So from here we had we're given the polar coordinates, and then we found the corresponding rectangular ones. Now we're going to go from rectangular to polar. Your first one is negative 1 and 1. Negative 1 and 1. So negative 1 and 1 is right here. So what degrees did I go? From here, how many degrees did I go? I went 90 degrees and 45, right? So it's going to be 3 pi over 4. So my angle is going to be 3 pi over 4. That's a 3. 3 pi over 4. So here, 3 pi over 4. Magnitude is what? What's my magnitude here?
The 1.
I have 1 and 1. So this guy here is going to be what?
2.
Square root of 2, right? Square root of 2. All right, so this would be your answer. I can also have went all the way over here, right? And then went negative, right? If I went from here all the way over here, that would have been 7 pi over 4.
70 degrees?
Yeah, so it's, no, 315, right? 315 all the way over here. Because I'm basically going negative 45, right? Right here. Then I'm going to go backwards that way, so it's going to be, right? Everybody get that? Everybody see that? I went backwards.
I'm going to have to reference my unit circle.
Instead of 7 pi over 4, they said negative pi over 4.
Which is the same thing, right? You want to do it that way?
Well, wouldn't you just, instead of going all the way around, you just go?
Yeah, it's the same thing, right? Because you're going to end up at negative pi over 4 plus 2n pi, right? So when n is equal to 1, you're going to get 7 pi over 4, right? It's the same thing. So that was that guy, that's that guy. We're good, we're good. And then let's do B. So B, we have 3 and 0, negative 3 and 0, negative 3 and 0. So that's this guy right here, right? So I started from here. My angle is what?
180.
Pi, right? My angle is pi, right? And my magnitude is 3. Right? Or I could go 0, stay here at the 0 angle, and go negative 3, right? Right? Everybody see that? Okay. So those are the two. We're good with that. And we'll take a break. This will be the end of part 1.